Hello and welcome back to Algebra 1-2, where we look at topics in Algebra 1, Algebra 2, and additional mathematics. In this lesson, we are looking at how to expand a plus b to the n using Pascal's triangle. And so, in this lesson, you're going to learn two things. One, you're going to learn about Pascal's triangle, and we are also going to learn how to use it to expand brackets. Before we get into Pascal's triangle, though, let's talk about how to expand a plus b squared and a plus b to the third power. So first, a plus b squared. This is equal to a plus b times a plus b. And in writing this out, we can use the distributive law to say a multiplied by a plus b, and this b multiplied by a plus b. So multiplying here, we have a times a, that's a squared, and a times b gives us ab. And here, b times a gives us ab, or ba, and b times b is b squared. Now these two are similar terms, so we can combine them to get a squared plus 2ab plus b squared. Now let's try to work out a plus b to the third power. A plus b to the third power can be rewritten as a plus b times a plus b squared. And since we already worked out a plus b squared, what we're simply going to do is to write down a plus b times a squared plus 2ab plus b squared. And multiplying now, we need to multiply this a times all of this. So it's a times a squared plus 2ab plus b squared, and all of that we're going to multiply next. B times a squared plus 2ab plus b squared. All right, let's get our multiplication on. Remember now, a times a squared gives us a to the third power. A times 2ab gives us 2a squared b. And a times b squared gives us ab squared. Let's write our plus there. Then b times a squared is simply ba squared, or you can write it as a squared b, no problem. B times 2ab gives us 2ab squared. It's a b times b. And b times b squared gives us a b to the third. Now there's some things in there that can be tidied up, so we're going to tidy them up. So notice we have a to the third here. There's a 2a squared b here, and there's also a squared b right there. And so we can combine them to get 3a squared b. This ab squared is also similar to this, so we can combine those again and get 3ab squared. And then we have our b to the third power. All right, so this becomes our answer. Notice a few things here. Notice that when we're writing out an expansion, that when it says a plus b squared, that notice that we start with the 2, the square, and then the a drops in power to 1, then it drops to 0. So we don't have to write it because a to the 0 would be 1, given that if our a is not 0. And then at the end, we now start with b squared. So it starts with the 2 here, then it goes to 1. Then b to the 0 would be here, but we don't need to write it because b to the 0 is 1. So the coefficients here are 1, 2, and 1. 1, 2, 1. Let's make a note of that. Same thing here, a plus b to the third. Notice that we start with 3a to the third, and a squared, then a. And then at the other end, we start with b to the third, then b squared, then b. All right, and the coefficients are, for this, 1, 3, 3, and 1. Now, notice that moving from a squared to a plus b squared to a plus b cubed, that the multiplication got a lot harder. So if we wanted to expand something like a plus b to the 5, you can imagine that going through this, that the multiplication is going to be significantly longer and significantly harder, a lot more writing to do. So as mathematicians, we need a faster, more efficient way to reproduce this expansion without going through so much work. There are two ways in which we can do this. The first way that we're going to look at today in this lesson is to use Pascal's triangle. And later on, we're going to be looking at how to use the binomial theorem to do this similar kind of expansion. So let's talk about Pascal's triangle first. But before that, who was Pascal? Since it's his triangle. All right. Pascal was Blaise Pascal was a 17th century French mathematician. He was many things. He was a physicist. He was an inventor. You might have heard, if you go research, you look up the Pascaline. It was developed by Pascal, and his ideas led to the development of modern computers that we use today. He was also a writer and theologian, so he was many, many things. And one of the things that he's known for in mathematics is this wonderful triangle of numbers, which doesn't stop here. It keeps going on and on forever. That gives us the coefficients of terms when we expand brackets of this sort. So when we expand a bracket of this sort, these are the coefficients we get. So a plus b squared gives us 1, 2, 1. A plus b to the third gives us coefficients of 1, 3, 3, 1. And so this is exactly what Pascal's triangle is doing. It is giving us the coefficients of the terms in the expansion of our brackets. So we start with 1, and then 1, 1. Going to do some more on that a little bit. And then these two now combine 1 plus 1 gives you 2. So in the next line, we have 1, 2, 1. In the next line, 1 plus 2 gives you 3. 2 plus 1 gives you 3. And then we continue with 1. Then 1 again. 3 plus 1 gives you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4. And it keeps going on like that. 4 plus 1 gives you 5. 4 plus 6, 10. 4 plus 6, 10. See? Then 5 plus 1 is 6. 10 plus 5 is 15. 10 plus 10 is 20. Etc., etc., etc. And we also always start and stop with 1. Now let's look a little bit more on it in detail. So if we are expanding a plus b to the n, now here n is 0. Now notice if you're expanding something, a plus b to the 0, as long as a and b are both not 0, then the result is 1, because when we raise to a 0 power, our answer is 1. Anything raised to a 0 power gives us an answer of 1. Okay. Now if it's a plus b to the 1, then simply what we're going to get back is a plus b. So the coefficients are going to be 1 and 1. So let's write that down. And as you can see earlier, when we expanded a plus b squared, we got 1, 2, 1, which is 1 plus 1 gives you 2. And of course, when we expanded a plus b to the third, we got 1, 3, 3, 1, which is 2 plus 1 is 3, 2 plus 1 is 3, and we continue with the 1 there. So continuing here, we start with 1, then we add 1 plus 3 gives us 4, 3 plus 3 gives us 6, 3 plus 1 gives us 4, and we stop with 1. And for the fifth power, we start with our 1, we add 4 plus 1, 5, 6 plus 4, 10, 6 plus 4, 10, and 4 plus 1, 5, and we end with 1. And remember what these are. These are the coefficients of the terms in our expansion of a plus b to the n, the coefficients of our terms. Now, let's look at how we can use that to expand something like this. So here we have 2x plus y raised to the fourth power. Let's write out Pascal. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. So this would be to the 0 power, a plus b to the 0, a plus b to the 1, a plus b square, a plus b to the third, and a plus b to the fourth. So this is the set of coefficients that we need to expand this. So if we wanted to expand a plus b raised to the fourth power, then guess what we're going to have? We're going to have these coefficients. Now remember how to write it out. Since we're raising a plus b to the 4, we start with a to the fourth, and then we go to a to the third, then we go to a square, and then we go to a, and then we start at the other end with b to the fourth, b to the third, b square, and then b. Then b to the 0 would be here, but b to the 0 is 1. Now let's drop in our coefficients. 1 plus 4 plus 6 plus 4 plus 1. All right, let's write in that 1 just to be consistent. So 1, 4, 6, 4, 1. Now we can use this to make our job here a lot easier. All we have to do now is to substitute these into this. So it's a to the fourth but here our 2x is going to become, our a is going to be our 2x, and our b is going to be our y. So we need to substitute these into this. So let's do that. So our 2x plus y raised to the fourth power is going to be, let's substitute this, a is 2x, so we have 2x raised to the fourth plus 4, that 4 times a to the third, remember a is 2x, so we have 2x raised to the 3, and then b is y, plus here 6, a square is 2x, so we have 2x square, then b square, and b is y, so we have y square, plus 4a, and a is 2x, so we put our 2x, 4 times 2x times y to the third, and then we end by writing down y to the fourth. Remember, y is b. Now, we're almost done. What we need to do now is just to get these numbers out so we can write out our expansion. So 2x to the fourth is the same thing as 2 to the fourth x to the fourth using our indices rules. So 2 to the 4 here is 16. So we have 16x to the fourth. Done with that one. 2 to the third would be 8, and 4 eighths make 32. So we have 32 x to the third y. 2 to is 4, and 4 times 6 here gives us 24. So it's 24y square. Let me jump in ahead of myself. 24x square, y square. And then here, 4 times 2, 8. So it's 8x y to the third. And then we end it off by writing down y to the fourth power. And there, instead of going through all that rigorous multiplication of this 2x plus y to the 4 different times, we can simply use Pascal's idea to write out the expansion of our sequence, of our bracket rather. Now, let's look at another one. Here we have 3x minus 2y to the third. So let's write out Pascal. Pascal starts with 1, then 1, 1, then 1, 2, 1, then 1, 3, 3, 1. So this is the one that we need because we're dealing with the third power. So this is the 0 power, 1, 2, 3. This is the third power, a plus b to the third. So a plus b to the third. If we write that out, we're going to get terms. Remember, this is 3, so we start at 3, a to the third. And then we have, let me just leave some space there. Then we have a square. Then we have a, and at the other end, we start with b. So we have b to the third, then b square, then b. And let's put in our plus, our coefficients. This is 1. Then the coefficient here would be 3. And the coefficient here would be 3. And the coefficient here would be 1. 1, 3, 3, 1. And all that we need to do now is to drop this into this. So 3x minus 2y to the third, if we want to multiply that out, we don't have to go through the rigorous, difficult multiplication. We can simply substitute. 3x would be our a, and minus 2y is our b. Okay. So here we have a to the third. So it's going to be 3x to the third plus 3 times x squared, which is 3x squared. And we put in our b term, which is minus 2y. So we have written down that one, plus 3 again. A, which is 2x. B, which is going to be minus 2y squared. And then for our final term, we are going to write down minus 2y to the third power. So there we have them. And now we simply need to go through and multiply these out to make sure that we get the answer that we need. So here we have 3x to the third power, which means 3x times 3x times 3x. And that gives us 3 times 3 times 3, which gives us 27x to the third. So that becomes the first part of our answer. Now let's look at the numbers that we have here. We have 3 squared, which is 9, and 9 times 3. So here, let me just write it out. So we have 3 squared here is 9, and we have a minus 2 here. So we need to multiply these out. 3 times 9, that's 27, and 27 times 2 is 54, but it's a minus 2, so it's a negative 54. So we're going to have minus 54 x squared y. Let's look at the next term now. Here, let's look at the numbers. 3 times 2, that's 6, times negative 2 squared, and negative 2 squared is positive 4. So we have 3 4 is 12, and 12 times 2 is 24. Let's make sure that we're 3 times 2 here. Yes, and then 2 2 is 4. Okay. All right, so we're going to have here plus. Oh, no, there's an error here. Let's fix that. Ah, there it is. That's a 3. Caught it. So what we should have is 3 times 3 times 4. Very good. So the 4 comes from here, negative 2 squared. That gives us 4. And then 3 times 3. I wrote 2x here. It shouldn't have been 2x. It should be 3x. All right. So let's multiply it. 3 3 is 9, and 4 9s make 36. So we end up with 36. Let's just go back to the other ink. 36 x y squared. And then for our final term, we have negative 2 times negative 2 times negative 2. That's negative 2 to the third, which means negative 2 times negative 2 times negative 2. And that, of course, is negative 8. And so we can simply write it down as minus 8y to the third. Now, as you can appreciate, this is a lot easier to do rather than going through the process of multiplying a times b times a times b times a times b, or in our case, multiplying 3x minus 2y times 3x minus 2y times 3x minus 2y. So Pascal's triangle is a really, really neat, very, very efficient way of doing this kind of expansion of brackets without going through the biting of nails and pulling of teeth where we have so much multiplication to do and so many possible mistakes that we can make. All right. So this is how we use Pascal's triangle to assist, to aid in the expansion of brackets such as this. And of course, you can raise it to larger powers, whatever the power is. The only trouble is then that we need to go through each time, well, unless you have a table of Pascal's triangle, which has many, many values, and write them out. But there are other ways to do it. And so, in a next lesson, we're going to look at how to use the binomial theorem, where we can calculate individual terms. So if you haven't subscribed to our channel, please do. And remember that you need to practice these things to make sure that they stick, to make sure that you get a good understanding of them. As Halmo said, the only way to learn mathematics is to do mathematics. So remember to practice, practice, practice. Make sure that you practice so that you can't forget it. And thank you so very much for watching. Until next time.